Assalamu alaikum, dear students. Today we are going to discuss the last topic of this magnetism and magnetic materials, that's magnetic materials. As you know, we have already discussed that atom as a magnetic dipole. So, in case of atom, when we derived the relation that's called Bohr magnetron, we find that every orbiting electron is associated with a magnetic moment. That magnetic moment mu b is equal to Eh by 4 pi m, and that is 9.27 into 10 power minus 24 ampere meter square. This is the magnetic moment associated with one orbiting electron. Or in other words, we can say every orbiting electron or revolving electron which is revolving in an orbit, it behaves like a tiny dipole. It has a dipole moment. So we can say that this dipole moment equal to Bohr magnetron, it is an intrinsic property of electron, because we know every electron is revolving in an orbit around the nucleus. So definitely it will gain magnetic momentum that's equal to Bohr magnetron. And this Bohr magnetron is responsible for the magnetic moment of atoms and molecules. You know, now there are various types of materials on the basis of how they can behave in external magnetic field. So we classify the materials. In here we classify the material in three categories according to their behavior in the external magnetic field. And that behavior according to the classification of these materials on the basis of behavior of these materials in the external magnetic field, this gives rise to the three types of magnetic materials. One is called diamagnetic. First is called diamagnetic. Diamagnetic materials. Diamagnetic materials. So what are the diamagnetic materials? Yeah, what are the diamagnetic substances? Those substances which are weakly repelled by the external magnetic field, or which are weakly magnetized in the direction opposite to the direction of applied magnetic field. Substances which are weakly repelled by the magnet or which are weakly magnetized in the direction opposite to the direction of applied magnetic field are called diamagnetic substance. So diamagnetic substance वो substances जिनको अगर हम एक्सटर्नल मैग्नेटिक फील्ड में लगाएंगे तो ये तो मैग्नेटाइज होते हैं, लेकिन उस अपोजिट टू द डायरेक्शन ऑफ अप्लाइड मैग्नेटिक फील्ड में, या दे आर वीकली रिपेल्ड बाय द मैग्नेट. फॉर एग्जांपल इसमें वुड आएगा, इसमें प्लास्टिक आएगा, इसमें ग्लास आएगा, बहुत सारे. दीज आर द एग्जांपल्स ऑफ डायमैग्नेटिक मटेरियल्स. They are not magnetized in the direction of applied magnetic field. So what is the cause of this diamagnetism? As I have already discussed in when I was discussing the Bohr magnetron, whether the material can behave as a paramagnetic or diamagnetic or ferromagnetic, that depends upon the electronic configuration of the material, electronic configuration of their atoms. For example, if we are talking about the element or compound in an element which have unpaired electrons in its valence shell, definitely when it has got unpaired electrons, so it will behave either as a ferromagnetic or it will behave as a paramagnetic. Where the substance which have paired electronic configuration, it will behave as a diamagnetic substance. For if we are talking about the compound, if the compound is having paired electronic configuration in their molecular orbitals, then it will behave as a diamagnetic. If it is having unpaired electronic, it will behave as a para or paramagnetic. Because we know every moving electron is having magnetic moment. So in spin, one is spin up and other is spin down. In case of pure electronic configuration, magnetic moment of one electron is cancelled by the magnetic momentum of another electron. That makes net magnetic moment zero, and that's why substance behave as a diamagnetic substance. So now we will discuss it. So diamagnetic substances are those substances which are weakly repelled or weakly magnetized in the direction opposite to the direction of applied magnetic field. सो डायमैग्नेटिक सब्सटेंस तो आपको समझ आएगा. एग्जांपल्स भी मैंने दे दी, लाइक वुड है, लाइक प्लास्टिक है, रबर है, और गिलास है. दीज आर पेपर है, दीज आर डायमैग्नेटिक बिकॉज they are not attracted by magnet, or they are weakly repelled, or they are magnetized in the direction opposite to the direction of applied field. Now second type is paramagnetic substance. Paramagnetic substance. Those substances which are weakly attracted or weakly magnetized in the direction of applied magnetic field. Those substances which are weakly magnetized in the direction of applied magnetic field. वो substances जिनको magnet weakly magnetize, they are weakly magnetized in the direction of applied magnetic field. So इनमें क्या होता है, जब हम पैरामैग्नेटिक सब्सटेंस को किस में लगाते हैं, एक्सटर्नल मैग्नेटिक फील्ड में, तो ये कैसे बिहेव करते हैं. तो ये तो इनका जो एक्चुअली जब हम मैग्नेटिक सब्सटेंस, इनका जो मैग्नेटिक मोमेंट होता है, दे एटम्स एंड मॉलिक्यूल्स ऑफ ए पैरामैग्नेटिक सब्सटेंस हैव नेट मैग्नेटिक मोमेंट, but they are randomly oriented. These moments are randomly oriented. So it makes the net magnetic momentum zero. For example, this is a strip of paramagnetic substance. So in absence of external magnetic field, these magnetic moments are randomly oriented, and so it makes the net magnetic momentum zero. When we apply the external magnetic field to this paramagnetic strip, these magnetic momenta, they get aligned in one direction. They arrange themselves, they orient themselves in a one particular direction. So that's why they get magnetized in the direction of applied magnetic field. So it gives net magnetic moment, it gives net non-zero magnet. In absence of electric field, they have zero magnetic field, they get magnetized, they get attracted by the magnet. They are weakly magnetized in the direction of applied. So these substances are called a paramagnetic substance. For example, paramagnetic substance में कॉपर क्लोराइड्स आते हैं, सोडियम, एंटीमनी, प्लेटिनियम, कोबाल्ट, अल्युमिनियम, क्रोमियम. These are the examples. अल्युमिनियम है, क्रोमियम है, मैग्नीज है, प्लेटिनियम है, एंटीमनी है. These are the examples of paramagnetic substance. Now what about the ferromagnetic substance? So ferromagnetic substances are those substances which are ferromagnetic substances. Now we will talk about the ferromagnetic substances. Ferromagnetic substance. Ferromagnetic substances are those substances which are strongly attracted by the magnet. or which are strongly magnetized in the direction of applied magnetic field. Those substances which are strongly magnetized by the magnet, or which are strongly uh, uh, attracted in the direction of applied magnetic field are called, they are called ferromagnetic substance. और ferromagnetic substance में क्या होता है, it is made up of magnetic domains. in ferromagnetic substance में ऐसा होता है कि ये जो मैग्नेटिक मोमेंटम ऑलरेडी प्रेजेंट होते हैं, देयर आर ऑलरेडी मैग्नेटिक मोमेंट प्रेजेंट, and they form the domains. They are called magnetic domains in a particular region. These magnetic moments इस रीजन में ऐसे बैठेंगे, और इस वाले रीजन में ये मैग्नेटिक मोमेंट्स ऐसे बैठेंगे, और इस वाले रीजन में ऐसे बैठेंगे, और इस वाले रीजन में ऐसे बैठेंगे. And these regions are very small, of volume of 10 raised to power minus 18 मीटर क्यूब. इतना बहुत कम वॉल्यूम होता है. और इन फेरोमैग्नेटिक डोमेन्स का जो 10 रेज्ड पावर माइनस, एक डोमेन में 10 रेज्ड पावर 11 एटम्स होते हैं, इनका मैग्नेटिक मोमेंटम होता है. तो इस तरह ये डोमेन्स बन. लेकिन इन एब्सेंस ऑफ मैग्नेटिक फील्ड they make net magnetic momentum zero. When we apply the magnetic field to these domains, when we apply the magnetic field to this ferromagnetic substance, these magnetic materials, they also adjust, they also orient themselves in the direction of these domains, or they arrange themselves in the direction of applied magnetic field. So इस तरह ये सारे domains एक ही direction में आते हैं on the application of electric field, and this gives the strong magnetic field to the ferromagnet. They are strongly magnetized in the direction, and it has also got a property. इस पैरामैग्नेटिक सबस्टेंस में क्या होता था, जब हम इसको एक्सटर्नल मैग्नेटिक फील्ड से बाहर निकालते थे, it becomes non-magnetic again. It does not retain the magnetic properties. But here in the ferromagnetic substances, when we bring it out from the magnetic field, external magnetic field, it retains properties. It still behave like a magnet. For example, when we rub an iron nail with a magnet, then this iron nail, it also starts attracting the object. This is because it is ferromagnetic. Ferromagnetic substance, they retain their magnetic properties. They have the two properties, retentivity and coercivity. Retentivity is, for example, in order to make their magnetic field again zero, you have to apply the negative magnetic field, or you have to apply the magnetic field in opposite direction. Then it will again become the zero magnetic field. It will become zero magnetic. So ferromagnet, that's why they are strongly attracted and they retain their magnetic properties. And coercivity is how much negative magnetic field you have to apply so that its magnetic momentum will become zero again after magnetizing a ferromagnetic substance. So it means that magnetic substances are of three types. One is paramagnetic substance, ferromagnetic substance, and diamagnetic substance. What are diamagnetic substances? Those substances which are weakly repelled by the magnet, or which are weakly magnetized in the direction opposite to the direction of applied magnetic field. They are called ferromagnetic substance. And those substances which are weakly attracted or weakly magnetized in the direction of applied magnetic field, they are called paramagnetic. They are called, and those substances which are strongly magnetized in the direction of applied magnetic field, and they are called ferromagnetic substance. And in ferromagnetic substance, there is nickel, steel, cobalt. They are iron, steel, nickel, cobalt. They are the examples of this ferromagnetic substance. So you have to keep this thing in memory, that on the basis of this behavior of the materials in the external magnetic field, we classify the magnetic materials. There are three types of the magnetic substance, that's para-dia and ferromagnetic substance. And you know that, and there is one another thing, that is, where, with the increase in the temperature, this ferromagnetic substance, it is converted into the paramagnetic substance. Now you know that the ferromagnetic substance has domains. When we increase the temperature of a ferromagnetic substance, these domains split, and now they arrange themselves. When we increase the temperature, a temperature is reached when this domain is split and it becomes a paramagnetic substance. They have now zero orientation. They start randomly behaving. We know in paramagnetic substance, magnetic moments are randomly oriented. So when we increase the temperature of a paramagnetic substance, its domain is split and magnetic moments gets randomly oriented, so it becomes a paramagnet. And the temperature at which the ferromagnetic substance becomes a paramagnetic substance, that's called Curie temperature. That's called a Curie temperature. So this was about the classification of magnetic materials. And now what we have to discuss, we have to discuss the properties of magnetic materials. Properties of magnetic, we have to discuss the properties of magnetic material. Now we will discuss the properties of magnetic materials. That's very important. So for example, in case of diamagnetic materials, so for example, first I will talk about the diamagnetic properties of diamagnetic materials. Properties of diamagnetic materials. Diamagnetic materials, first property, they are weakly repelled by the magnet or weakly magnetized in the direction opposite to the direction of applied field. This is the first property. And second property is a freely suspended diamagnetic rod sets itself slowly perpendicular to the direction of applied magnetic field. For example, if this is magnetic field, when we suspend a freely diamagnetic rod, it will adjust itself perpendicular to the applied magnetic field. Perpendicular to the applied. Where a freely suspended paramagnetic rod sets itself quickly in the direction of paramagnetic this sets itself opposite to the direction of a freely suspended paramagnetic rod. Diamagnetic rod sets itself slowly perpendicular to the direction of applied field. But a freely suspended paramagnetic rod sets itself slowly in the direction of applied magnetic field. A freely suspended ferromagnetic rod sets itself quickly in the direction of applied magnetic field. And diamagnetic substance, they are weakly repelled by the magnet, and paramagnets, they are weakly attracted by the magnet, and ferromagnet, they are strongly attracted by the magnet. And third thing is that's about the magnetic permeability. Magnetic permeability. What's magnetic permeability? It is magnetic field induced per unit magnetizing field. Magnetic permeability mu, it is B divided by H. This is magnetizing force or magnetizing field. This is magnetic induction per unit magnetizing field in a substance. Their permeability is less than 1. For in case of diamagnetic materials, their permeability is always less than 1. B by H for diamagnetic, it is less than 1, and B by H for paramagnetic permeability, that's greater than 1, and B by H for ferromagnetic, it is much greater than 1. This is para, this is dia. Magnetic permeability for diamagnetic is less than 1, para it is greater than 1, but it's much greater than 1. And also magnetic flux density. Magnetic flux density for diamagnetic substance is less than iron. Magnetic flux, that's magnetic field lines passing through that material. it is less than air. For diamagnetic substance, magnetic flux density is less than air. For this paramagnetic substance, it is greater than air. Magnetic flux density is greater than air, and for it is much more than air, much more than air. And also magnetic intensity, yeah, magnetic susceptibility, intensity of magnetization. Intensity of magnetization has negative value. For diamagnetic substance, it has positive value. Positive value, it has more positive value, intensity of magnetization. And third is magnetic susceptibility, that is how easy it can be magnetized. Its magnetic susceptibility is less than 1. Ma- Magnetic susceptibility is less than 1. It has negative value, it has negative value. Magnetic susceptibility has negative value for what? Diamagnetic substance. For paramagnetic substance, it has positive value, but it's less than 1, and it has more positive value, it's greater than 1. This was about and also it has a number of the properties, so you have to remember these properties. So now I will once again I will repeat these properties. First, diamagnetic substance, they are weakly repelled by the magnet. Paramagnet or weakly attracted, and ferrous, they are strongly attracted. Second is a freely suspended paramagnetic diamagnetic rod sets itself perpendicular to the direction of magnetic field. Ferromagnetic rod sets itself in the direction of applied magnetic field but slowly, whereas paramagnetic rod sets itself quickly in the direction of applied magnetic field. And third, we intensity of that's magnetic permeability. Magnetic permeability is less than 1 for paramagnetic substance. For paramagnetic, it is greater than 1. It's much more greater than 1. And magnetic flux density, it's less than air. Number of magnetic field for diamagnetic. For paramagnetic, it is greater than air. It's much more greater than air. Intensity of magnetization, it has less positive value but less positive. It's less than intensity of magnetization is negative value. It has got negative value. It should not be, because it is magnetized in the opposite direction of the magnetic field, so it has negative value. It has positive value. It has more positive value. Magnetic susceptibility, it has got negative value because it's weakly repelled. It has less positive value or less than 1. It has more than 1. It has more positive value for the susceptibility. These were the properties of this paradigm and ferromagnetic substance, and this is very important question. It is asked in the examination. So this was the last question, and it is theoretical question. Even though you can easily go through the books and you can find it, it's not so much. There is no mathematics involved in this, and you have to remember this thing, that on the basis of behavior of the materials in the external magnetic field, there are three categories of the magnetic materials: paradiac and ferromagnetic. And you have to remember that you know that for these magnetic materials, when we talk about the magnetic materials, it means that you should know that you should remember that one thing: only those substances are magnetic which have unpaired electrons in their valence shells. If you are supposed to sometimes to calculate, for if it has 3 unpaired electrons, then it has 3 Eh by 4 pi m magnetic moment should a particle substance is having. So in case of these transition elements, where you know that in D or D block elements, you know they have the properties of various properties, magnetic properties and color compounds, etc. This is because of these unpaired electrons. They are responsible for their magnetic properties and etc. And that will you discuss in chemistry. And this was about this magnetic magnetism and magnetic materials. Now in the next lecture we are going to electromagnetic induction, and that has already been discussed. Is the lectures of electromagnetic induction, and let's see which unit will be the next. Okay, thank you.